Yo, yo, yo! Grandmaster C here, sporting the Freshie Q hat in the house. Okay, guys, so for this one here, we are looking at a limiting reactant and we're going to look at percent yield today. How to work it. Now, you guys should have already downloaded your packet that already has the whole thing on there, percent composition, empirical formula, things like that. That would be an important thing to do. Okay. So I'm not going over the entire packet with you, but do remember that there's a couple of parts you're going to need to turn in. Okay, let's get down to business. We talked about limiting and excess reactant in remote speak, so to speak. And the idea is in any chemical reaction, it's not going to go on forever. Something is going to stop the chemical reaction from happening. Okay? The question is, what is it? And the answer is the limiting reactant. Now, you have limiting reactant, you have excess reactant. Now, you could have three different reactants, three different ingredients, and you have a certain amount of each. The one that is going to run out first is going to be your limiting reactant, right? Excess reactant, on the other hand, just simply means you have more than enough to complete what you want for your chemical reaction. Whether you're making something or you're breaking something up, doesn't matter. The idea is still the same. So this part of the packet that you're on here, this is where you're working with limiting and excess reactants. So let's get to it. Define limiting reactant, that is on your notes. Again, define excess reactant. That's pretty straightforward. So here, you're given a situation, and I'm asking you to identify which reactant is the limiting reactant and explain why is it the limiting reactant. Pretty important concept. There are no numbers here. This is just the concept here. So, you dropped a red gummy bear into the test tube full of boiling potassium chlorate. That's KClO3 liquid. It comes in a powder normally. You heat it up, it becomes a liquid because it melts and it kind of boils too. It's a really cool reaction. The reaction happens and smoke is made without setting off any smoke alarms, unlike what happened to me some years ago. The reaction stops. Okay, so something ran out, right? You look inside the test tube and you see a piece of red gummy bear that is unused and everything else is used up. What is the limiting reactant and how do you know it's the limiting reactant? Now let's look at some facts here. Okay, this is the analysis that you need to know. You've got two things in the test tube, right? You have the red gummy bear right here, okay? You have this, right? You have the red gummy bear right here, right? You got the red gummy bear. That's a piece of information you need. And you have the potassium chlorate. So you got those two things in there in that test tube. That's all that's going. Now you've got the flame underneath. It's heating up the test tube and blah, blah, blah. Okay, that's part of the reaction, but it's not a reactant. You're just adding heat to the reaction to make it happen. Now you go further down. The reaction happens and smoke is made without setting off any smoke alarms. Okay, the reaction stops. Aha. You look inside the test tube and you see a piece of red gummy bear that's left. That is unused and everything else is used up. Wow, check this out. You're after certain pieces of information. You know what's inside the test tube, right? You've got a red gummy bear, you got potassium chlorate, you have a reaction, okay. Reaction stops. Cute. You look inside the test tube and you see a piece of red gummy bear that is unused. Okay, that's a key thing, unused, and everything else is used up. What is the limiting reactant, and how do you know it is the limiting reactant? I'm not giving you the answer on this one. I gave you the tools as to how to analyze it. Notice how I did the different colors. See, this is an advantage that you have, that you can do this in Word. It's great. It's a nice advantage to do. Just something to think about. Okay? All right, let's move on. So now I want to move on to the next thing here. Percent yield. So we're in the next page, and it says find the percent yield of the following reactions. Okay. Now, remember something about the percent yield. The percent yield is literally, you've got two things. You've got an actual yield and a theoretical yield, right? The actual yield is what you physically make. You measure it in the lab. That's your actual yield, the real world, okay? Theoretical is perfect world. Everything goes great, okay? Think of it as the perfect date. Your theoretical is your perfect date night. Your actual is what you actually got. Like the person acting like a middle schooler. That would be an actual. Theoretical, everything's cool. Okay? Okay, let's do this. So there's a formula that's involved in this. Okay? So I'm going to go and type that in, actual yield, and I'm going to use the slash mark as a division sign. Now, if it makes it easier for you, you could actually put in an actual division sign. You could go insert, right? You could go insert, go into symbols, and then find it. Now, in my case, you know, I find it easy. But if you're sitting there going, you know, Canu, don't have that time, okay, not a problem. Just go ahead and use the slash mark like this. That will tell me, hey, this is a division sign. Okay, so now, so I have actual yield divided by theoretical yield. Now, I want to point something out. I'm going to take this whole thing as one number, okay, as one number like this, and then I'm going to multiply it. Notice the big X. I'm going to multiply it times 100. And that, ladies and gentlemen, is going to equal my percent. That's what it is right there. Okay? So that's what it is. That's what it looks like. That's the actual formula in there. You can feel free to type it up. See, that's the thing. With Word, you can make all those adjustments. You can save a copy for yourself, upload the copy, you know, to the Cringe Master, and you're good to go, because that's actually the first couple of parts. That's actually for a real grade. Okay, so let's look at it. So let's look at this problem here. Okay, what is the percent yield if the theoretical yield of ammonia is 1,800 grams, but you actually measured 1,500 grams of ammonia in the lab? Now, you're still going to need a calculator, but here's a trick you can do. You could write this down. You could. In fact, I'd prefer that you write it. Okay? Because arguably, you could go and copy off of somebody else. You could. Now, what I could do, what you can do, is write it out on a piece of paper. Take a picture and paste it on the paper. Okay? So that's what I would want you guys to do. Write it out on a piece of paper, then you're going to take it like on a piece of paper, and you're going to do it like that. Okay? That's what I want you guys to do, because that way I know you guys actually did the work, as opposed to your buddy sends you the paper and, oh, it's copy and paste. Because here's the thing, if people start swapping pictures, the handwriting is not okay. I don't want to go through the process of cheating, guys. I really don't want to do that. That's not the idea. I want you guys to know this stuff. I'm giving you the time. I do have the office hours, okay? So I want you to know that. All right. So for this, I'm going to go ahead and I'm going to do that a la word. So I know my formula. My actual yield is 1,500 grams, and I'm going to divide that by 1,800 grams. Now I know that I've got to put it in parentheses like so, times 100, and that's going to equal whatever percent, which now means I have to get a calculator. Yep, you got to need one. Okay, so 1,500 divided by 1,800 equals, so I got 0.83. That's my decimal. Okay, now I multiply by 100 and I walk away with 83%. Okay, so you're going to write it on a piece of paper, take a picture and put it on the paper, and that way you can still upload it to me. You'd say, but Canu, how do I go and do how do I do that? Okay, all right. How to paste a picture. Click insert. It's the top bar up there. Whoops, my spelling is terrible. It's late Saturday night. Boom. Click insert. Okay, that's the first thing. Then you will go and click picture. Next one. Click your picture. Position. Place your mouse where you want the picture. Right click the mouse. Select paste. Adjust picture as necessary. That's it. That's all that it is. Okay, so let me go ahead and show you what that would look like. Okay, I'm going to go ahead and I'm going to pick a picture. Doesn't matter which picture, because if you master this, you can do so much on this. Okay, so I'm going to go ahead, I'm going to insert, I'm going to find pictures. Okay, now you have to look through your directory. Okay, I'm going to see if I have anything in my regular pictures file. Okay, you notice I got a lot of pictures here. Well, that's for very different things and whatnot. So I'm going to go ahead and I'm going to go to memes. Okay, and I'm going to pick this one. And notice I'm going to include, okay, insert like that. And you'd say, that's a pretty big picture. Yeah, it's a very awesome picture. Okay, so now if you notice, the picture's kind of big. How do I solve that? Well, what you can do, you notice you can take your cursor, go see where it is at the corner there. You hold, you click and you hold, and then you drag, and you notice how the picture gets smaller. And there you go. You can leave it like that. In fact, actually, you don't even need to select paste. It will do it automatically for you. So you just adjust the picture as necessary. Okay? That's it. That's all you got to do. All right? So, that being said, ladies and gentlemen, I'm calling it. So, ladies and gentlemen, this is at this point, when you're hearing me, I am speaking to the future. You're staring at the past. Ooh. Some people might be thinking, okay, can you do a jump scare? No! Okay, guys, that's it. That's it for this particular one. All right? You take it easy. Have a good night, and I will see you later. God bless you. And you know what? Hey, Jesus loves you.